Welcome to the Deep Dive, the show engineered to cut through the information noise and get you truly well-informed quickly.
Yeah, in today's digital landscape, we're all swimming in just this deluge of data.
Absolutely.
Yeah.
Constantly searching for that elusive shortcut to deep understanding, that aha moment that sticks.
Right, we all want that clarity
Yeah.
fast.
Will, you found it.
That's right. Today, we're taking a deep dive into something incredibly powerful. The profound synergy between Google Cloud's data and AI tools.
Okay.
We're talking about BigQuery, Gemini, and Vertex AI.
Right.
And these aren't just individual products.
Right, they work together.
Exactly. They're an integrated ecosystem that's not merely optimizing tasks, but fundamentally transforming the very role of data professionals across the board. From engineers and analysts right through to scientists.
So fundamentally transforming, that's a big claim.
It is, but I think it holds up.
Okay. So our mission here is to unpack how these technologies are enabling capabilities that were once complex, incredibly time-consuming, or frankly, maybe even deemed impossible.
Yeah, things that just weren't practical before.
We're not just going to tell you what they do. We're going to explore how they do it and why it fundamentally changes the game.
And we'll show you through specific real-world journeys, things like predicting equipment failures before they even happen.
Which is huge for manufacturing.
Huge.
Oh.
Or forecasting sales with remarkable speed, even generating personalized marketing strategies that really hit the bullseye.
So get ready for some genuine insights, maybe some aha moments, and hopefully a crystal clear understanding of what makes these innovations so impactful.
And we'll highlight some surprising facts, too, about the speed and, the scale at which these transformations are now possible.
Okay, let's unpack this. Let's start with a real-world scenario. Imagine you're a data professional. Let's call you our data pro for this journey.
Yeah.
And you've just stepped into a new manufacturing company. Your immediate high-stakes task: to transform a reactive manufacturing plant dashboard.
The kind we see all the time.
Exactly, the kind that only flags problems after they've already occurred, leading to costly downtime and, everyone's scrambling.
Firefighting mode.
Right, into something truly proactive, something that predicts issues before they strike.
That's the dream, isn't it? The stakes here are incredibly high. We're not just talking about minor inconveniences.
No.
Keeping an entire factory running smoothly by preventing unexpected downtime can save millions. Literally millions in lost production.
And avoid safety issues, too.
Absolutely. Avoid potential safety hazards, maintain customer trust. This isn't just about operational efficiency. It's about building genuine operational resilience and, frankly, a competitive edge.
And your trusty sidekicks on this critical mission, moving from constantly putting out fires to intelligently preventing them.
Let me guess.
Gemini, BigQuery, and Vertex AI.
Got it. The core toolkit.
They're going to be the backbone of this transformation.
Okay, so let's walk through the Data Pro's initial challenge. It usually starts reactively, right?
Typically, yeah.
Our Data Pro opens their Looker dashboard. Now, for those maybe less familiar, Looker is Google Cloud's business intelligence and data exploration platform. It's really powerful.
More than just static charts.
Oh, yeah. It enables interactive reporting, self-service analytics, even creating data applications, makes insights accessible across the whole organization.
Right.
So immediately, a critical red flag pops up. Throughput, product output, at one specific plant has suddenly dropped below target.
Okay, the classic operational emergency.
Exactly. This is the kind of immediate issue that demands rapid diagnosis to mitigate the impact.
And here's where it gets truly fascinating and different from the old way. Instead of the traditional approach, manually sifting through mountains of log files, trying to cross-reference sensor data, pinpointing the why through laborious queries.
Which could take hours, right? Or even days.
Or days, involving multiple teams. Our data pro simply types a natural language question right into Gemini within Looker.
Directly in the dashboard.
Directly in the dashboard. Imagine just asking, why did the throughput drop at 2 p.m.?
Wow. Okay, so what happens then? What kind of answer do they get?
Well, what's truly impressive here is that Gemini doesn't just give a generic answer. It intelligently provides immediate contextual information.
Like what?
Like identifying which specific production line experienced the drop. But it goes far beyond just a simple answer.
How so?
Gemini proactively suggests crucial follow-up questions.
Like prompt engineering, but for analysis?
Sort of, yeah. Like which metrics correlate with the dip? This isn't just answering a question. It's actively guiding the data pro directly towards the root cause.
Which in this example points to equipment issues.
Exactly. This dramatically shortens that whole diagnostic cycle.
And I bet it gets even better.
It does. Gemini can pull relevant machine statistics from routine diagnostics, often derived from this huge stream of IoT sensor data that's constantly flowing into BigQuery.
Right, tapping into that real-time data feed.
Which allows the data pro to give technicians precise, actionable information about what's wrong before they even arrive on the factory floor.
Okay, that's huge. So the tech isn't walking in blind.
Not at all. This is about instant, intelligent problem diagnosis. It turns what was once a reactive, time-consuming problem-solving process into an almost like predictive intervention.
It empowers the technicians. They show up with the right tools, the right knowledge, ready to fix the specific problem efficiently.
Exactly. So understanding the immediate problem naturally leads to the bigger strategic goal.
Moving beyond firefighting.
Right. The data pro now needs to move from firefighting to prevention. The next step is building a preventative maintenance model.
Okay, the proactive part. To predict future downtime before it cripples operations.
This shifts the entire paradigm from fixing breaks to preventing them altogether, ensuring continuous production, and, minimizing those losses.
So how do they start building that model? Where do they go?
To do this, they move over to BigQuery Studio. And it's not just a metaphor for an all-in-one workshop. It really is a unified development environment right within BigQuery itself.
What do you mean?
Meaning you can write SQL, you can execute Python notebooks, manage version control with Git integration, deploy machine learning models, all from a single interface.
So it eliminates that common swivel chair problem. You're not jumping between 5 different tools.
Precisely. It significantly streamlines the entire data workflow.
Okay, so they're in BigQuery Studio. What's the first step there?
Within BigQuery Studio, our data pro easily locates a promising throughput table. They use BigQuery's data profile tool.
What does that do?
It provides a quick, high-level understanding of the data's quality, its completeness, the distributions, the content. You get a feel for the data fast.
Okay, basic data exploration.
But here's the truly clever part, the bit that really augments the data professional's work. Gemini has already analyzed this data in an Insights tab.
Already analyzed it.
It seems to proactively scan the metadata and maybe sample the data. Then it suggests relevant business questions the data pro might want to answer, or patterns they might want to explore based on the structure and content.
Wow. It's like having a smart assistant giving you ideas directly from the raw data.
Exactly. Highlighting potential areas for exploration you might not have even considered yet, really accelerating discovery.
And does this only work if all the data is neatly sitting in Google Cloud?
That's another key point. No. Even if some critical reference data may be legacy operational logs or, say, supplier data lives in another cloud environment like AWS or Azure.
Which happens all the time.
Right. BigQuery can seamlessly connect to it. This highlights its powerful integration capabilities, ensuring you have a complete, holistic picture regardless of where your data is stored.
How does that seamless connection work, practically speaking?
From what I understand, it leverages technologies like BigLake. BigLake basically lets you create a unified metadata layer over data wherever it resides: Google Cloud Storage, AWS S3, Azure Data Lake Storage.
So you query it through BigQuery as if it's local, but the data doesn't necessarily have to move.
Exactly. It reduces data movement, ensures consistent governance, all without needing complex, time-consuming ETL pipelines just to join data sets.
Okay, that multi-cloud capability is seriously powerful. So now they understand the data, they can access it all. What about building the actual predictive model?
Right. Our data pro decides to use a Python notebook within BigQuery Studio. This really emphasizes the flexibility and collaborative nature of the environment.
Python notebooks are standard for data science work.
They are. It allows for complex data manipulation, statistical analysis, advanced model development using all the popular data science libraries: Pandas, scikit-learn, TensorFlow, you name it.
And here's where the generative AI really kicks in to accelerate productivity, right?
This is where it gets really cool. Our data pro simply asks Gemini, using a natural language text prompt, right within the notebook.
Just types a comment or something.
Pretty much, yeah. Tells it to generate the SQL code for a logistic regression model.
Okay, logistic regression. Why that specifically?
Well, this model is specifically designed to predict throughput based on available attributes, things like machine temperature, vibration levels, historical performance metrics from the data they've gathered.
Right. Logistic regression is a cornerstone for predictive analytics, especially for these binary classification problems like predicting whether a machine will fail or not fail, a yes or no.
Exactly. It gives you the probability of an event, which is exactly what our Data Pro needs for that early warning system.
And the real marvel here, you're saying, is that Gemini instantly provides the complex SQL code needed for this.
Instantly. And get this, even handling intricate joins across different clouds, if that temperature data is in one place and vibration in another.
It writes the SQL to join them correctly. That's not trivial.
Not at all. That often requires deep SQL expertise and knowledge of multiple data schemas, table names, join keys.
So give us that analogy again. How should we think about this?
It's like telling a highly capable AI coding assistant, generate the SQL query to predict if this specific machine is likely to break down in the next 24 hours, considering its temperature readings from our AWS data lake and its vibration data from our on-prem sensor database, joining them on their timestamp and machine ID.
And it just writes it.
It just writes the perfectly formatted, complex, potentially multi-cloud SQL code for you. It saves not just typing time, but also the mental effort of remembering syntax, table names, join conditions across this potentially distributed data landscape.
The key benefit here seems pretty clear then. It's transformative.
Absolutely. Gemini dramatically speeds up every stage. That initial data discovery, answering complex business questions, generating intricate SQL code, extracting insights.
And crucially, all of this happens while ensuring that your valuable, often sensitive data remains secure and governed within BigQuery. You're not exporting it somewhere else.
Right. This integrated intelligent assistance is a genuine game changer for the speed and agility of data teams.
You could iterate so much faster.
Exactly. They can move from a hypothesis to a deployed model in potentially days instead of weeks or months, or tackle projects previously deemed too resource-intensive for their existing teams.
Imagine the competitive edge that brings for businesses that can adapt their data strategies at that pace. It's huge.
Okay, so our Data Pro now has a robust model that can predict potential equipment issues. Pretty great.
But not the end of the story.
Not quite. They want to go even further, moving beyond just predictions to providing concrete, actionable recommendations directly to the plant operators.
Making it truly useful on the ground.
Right. And they know that unstructured inspector reports, some text documents, technician notes, observations from manual checks, hold crucial, nuanced clues.
The stuff that isn't typically in structured database tables. Rich context, but hard to use.
Exactly. Incredibly difficult to process at scale using traditional methods.
This sounds like a job for large language models.
Precisely. This brings us to the profound power of retrieval augmented generation, or RAG.
RAG. Okay, I've heard a lot about this. Explain it simply.
Okay. It's a truly fascinating and critical technique for making LLMs enterprise ready. The core concept is about combining the immense general knowledge of a large language model,
like Gemini or GPT-4.
right, with your own proprietary, up-to-date company data, in this case, those detailed inspector reports.
So grounding the AI in reality.
Exactly. This creates an agent, the LLM, that can use tools to actively query and pull facts from its own private, trusted data sources before generating a response.
Why is that so important?
The significance of RAG is that it makes LLM responses far more reliable and, crucially, significantly reduces what we call hallucinations.
That's when the LLM sometimes just
Right.
make stuff up, right? Plausible sounding, but false.
Exactly. And historically, this unpredictable nature made LLMs unsuitable for sensitive, business-critical operations like preventative maintenance, where accuracy is absolutely paramount.
Right, changes that.
It changes that by rooting their responses in verifiable proprietary data. It transforms them from a potential novelty into a reliable decision support system.
Can you give us that analogy again for our RAG?
Sure. Instead of just asking an AI to guess maintenance recommendations based only on its general internet training data, RAG is like giving your AI a vast, meticulously organized, and specific library of your company's actual inspector reports to read and find facts from before it tries to answer.
Like giving it the specific textbook for the test.
Exactly. This empowers the AI to provide recommendations that are much more informed, precise, and less prone to mistakes because they're based on your unique operational history, not just generic patterns.
Okay, that makes sense. So how do they actually implement RAG with those inspector reports? They're just text files.
Right. To make those unstructured reports usable for this ARG process, our Data Pro utilizes BigQuery's new ML inference engine.
Which is powered by?
Powered by Vertex AI's large language models running securely within BigQuery. They achieve two critical steps here. First, they summarize the unstructured inspector reports.
Boiling down long text into key points.
Right. Makes the information digestible for the LLM. Second, and equally important, they create vectors.
Vector embeddings. Explain those again quickly.
They're high-dimensional numerical representations of the text. Think of them as unique, multifaceted digital fingerprints for each report.
Oh.
By transforming text into these vectors, BigQuery ML allows us to perform lightning-fast semantic search.
Meaning searching for meaning, not just keywords.
Exactly. We can find reports that are conceptually similar even if they use different words or phrasing just by measuring the distance between their vector fingerprints in this high-dimensional space.
And that's how the system intelligently retrieves the most relevant context from those reports for the LLM.
Precisely. It vastly improves the LLM's accuracy and the relevance of its generated recommendations. It's finding the right textbook pages automatically.
Got it. So summaries and vectors are created. What's next?
Once those summaries and vectors are ready, a carefully constructed question or a prompt is fed into the LLM, along with the newly processed and vectorized reports retrieved via semantic search.
The relevant context.
Right. The LLM then uses this enriched contextual information to generate concrete predictive actions and precise recommendations for the plant operators.
So instead of just check machine X,
It might suggest check hydraulic fluid levels on machine X production line 3, as similar past incidents documented in reports, report ID 123, report ID 456, involved fluid degradation under high load. Specific and actionable.
give us that AI assistant analogy one more time here.
Okay. Your AI assistant, now equipped with this specialized knowledge base synthesized from all the summarized inspector reports thanks to RCAG and BigQuery ML, is truly an expert on your equipment's history.
Yeah.
When you then ask it, based on past issues documented in our reports, what specific steps should we take to prevent future downtime on equipment showing these early warning signs? It intelligently suggests actionable steps, drawing directly from that specialized, verified knowledge base, not just generic internet knowledge.
That connection to specific internal data seems key.
It's absolutely crucial for enterprise reliability, and the real-world impact of this entire workflow is truly remarkable.
How so?
This end-to-end process, spotting an anomaly, diagnosing it, building a predictive model, and then generating actionable, precise recommendations from unstructured text data.
Which normally involves so many steps and different tools.
Right. It would have taken traditional data science methods a vast amount of time, potentially days or even weeks of manual data integration, model building, textual analysis by humans.
And now?
Now it's completed in mere minutes with just a few lines of SQL or Python code. And critically, it all happens directly within BigQuery, where the data remains secure, governed, and compliant with enterprise standards. No data leaving the secure environment.
So with the Data Pro's skill augmented by these powerful tools, the entire prediction and recommendation pipeline is successfully operational. It's deployed.
Right. Moving beyond just experimentation to real-world impact.
And the immediate tangible payoff, what does the factory floor see?
The predictive results and those specific actionable recommendations are now prominently displayed directly on the manufacturing plant dashboard in Looker.
So it's right there for the operators.
Exactly. It's no longer just showing what has happened, but clearly indicating what might happen and, crucially, what to do about it.
Closing the loop.
And the Data Pro can even go a step further, leveraging Looker's action framework.
What does that let them do?
Lets them automatically notify the right people, be it maintenance technicians, supply chain managers, maybe even the operations director, to take immediate action on these new recommendations.
So triggering workflows automatically based on the AI's output.
Precisely. It closes the loop entirely, transforming raw insights into immediate, guided intervention, often before a problem even fully manifests.
The ultimate outcome seems pretty clear then.
Yeah, the equipment monitoring dashboard has been utterly transformed, from a reactive problem logging system to a truly proactive, predictive, operational control center.
Ensuring optimal plant operation, minimized downtime, maximized output.
And with all that time saved, the Data Pro has truly elevated their role. They're not just processing data, they're a strategic partner delivering immense value. And maybe, just maybe,
They can relax a little bit.
they can relax a little bit. It's a testament to the power and efficiency of Google Cloud's AI and data tools working together in synergy.
Okay, that manufacturing example is compelling. Now, let's shift gears. Let's explore another common challenge, but from a different perspective.
Whose perspective this time?
That of a new data analyst. Imagine you're that new analyst joining a sales team.
Okay, first week on the job.
Exactly. And your first big task is to predict product sales using a time series forecasting model. You're feeling the pressure because you're new to the team, new to its specific data. There's usually a steep learning curve.
Definitely. Getting up to speed takes time.
But here's the elegant, empowering solution in this new world. You immediately turn to BigQuery.
Google's data warehouse.
Right. And its incredibly helpful built-in AI assistant, Gemini. It's like having a seasoned mentor and a comprehensive knowledge base right there with you, guiding your every step from minute one.
Okay, so how does this new analyst start?
You start in BigQuery Studio again, that central workspace. The first thing you do is enable Gemini's crucial features. Auto-completion.
Suggesting code as you type?
Auto-generation.
Writing code from natural language?
And explanation.
Interpreting complex queries.
These are the tools that will truly accelerate your learning and productivity right from day one.
So instead of bugging colleagues or searching through wikis...
Exactly. Instead of sifting through endless internal documentation or asking colleagues about data sources which can be inefficient and interruptive, you simply open the Gemini chat interface within BigQuery Studio.
And just ask.
Use natural language. Ask something like, how do I learn which dataset and tables are available to me in BigQuery?
Then what does Gemini do?
It immediately provides several clear methods. And when you follow up, say, asking for in the console instructions, it gives clear step-by-step guidance.
So it helps you navigate the interface.
Yeah, it breaks down that initial barrier of facing a new data environment. Following Gemini's instructions, you quickly navigate the BigQuery console, find your team's sales dataset, examine its tables and schema.
Remind us what schema means again.
Sure. The schema is essentially the blueprint of your data tables. It defines the columns, their data types like text, numbers, dates, and how they relate to each other. Understanding the schema is absolutely foundational for querying and analyzing data effectively.
And Gemini speeds that up.
Significantly. You can even preview the raw data itself. You're getting oriented incredibly fast, gaining confidence in what used to be an unfamiliar landscape.
And can it help with getting data into BigQuery too?
Absolutely. Gemini's versatility doesn't stop there. You could also ask it to guide you on how to load various types of data into BigQuery, whether it's from, say, CSV files, external databases, or streaming sources, if that were part of your task. It really is a comprehensive, always available guide.
Okay, but what about code that's already there? Teams usually have existing queries.
Right, and that's often a big hurdle for newcomers. What's truly invaluable here is how Gemini helps you understand existing queries. Your sales team likely has complex SQL queries already written, maybe for monthly reports or specific analyses.
So how do you figure out what they do?
To quickly grasp what a complex query does, let's say one that calculates the top 10 users by average sale price with multiple joins and aggregations. You simply highlight that query right in the SQL editor.
The existing code.
Yeah. And ask Gemini to explain this query.
Give us that tutor analogy again.
It's like having a super smart tutor who instantly looks at the code and tells you, okay, this complex SQL query is designed to calculate the average sales value for your most active customers. This join brings in customer details. This where clause filters for recent activity. This group of IY calculates the average per customer. And this order by and limit show you the top 10.
Wow, that saves potentially hours.
Exactly. Precious minutes or even hours of trying to decipher complex code that someone else wrote. It dramatically accelerates your ramp-up time on a new team. Okay, so now our new analyst understands the data, they can navigate. What about doing their own analysis? Generating new insights.
Right. Now that you understand the data and how to navigate it, you want to dig deeper to analyze it and generate new, specific insights relevant to sales patterns.
What's a typical first analysis?
Maybe you need to know total sales for each product on each day. A pretty foundational request for any sales analysis.
Okay, how do they get that?
Instead of laboriously writing that complex SQL yourself, maybe forgetting a group by Y clause or using the wrong aggregate function like count instead of SUM.
Common mistakes.
Very common. You prompt Gemini directly within the SQL editor. You just start a line with a hashtag, and then your natural language requests like hashtag, write a query for total sales for each product on each day.
So just tell it what you want in English.
Basically, yeah. Think of it like telling your AI assistant, I need a precise report summarizing daily sales for every single product broken down by date, and it automatically writes the complex, optimized SQL code needed to generate that report.
It transforms intent into code.
Right. Eliminating syntax errors, ensuring correct logic, significantly speeding up query development.
So Gemini suggests a query.
Yep. You review it, maybe make a couple of minor tweaks like changing a date column alias to be more readable or adding a specific order by clause to sort chronologically,
You run it.
and instantly you get the daily sales trends for each product. This granular data is vital for identifying sales patterns, recognizing sudden spikes or dips, understanding product performance over time, and it all happened in a matter of seconds.
Okay, that's analysis. Now for the main event, the forecasting model.
Exactly. Building and forecasting with a machine learning model. Your core goal as the new analyst is to predict future sales.
Let's say a teammate helps out.
Right. A teammate shares a SQL query designed to create a time series forecast model using BigQuery ML.
But before just running it,
Before you even run it, you decide to leverage Gemini's explanation capability once more. You paste the query into the chat and ask Gemini to explain this query.
and Gemini tells you.
It quickly tells you the query's intent. It's designed to create a time series forecasting model using a specific and powerful algorithm called ARMA+.
Yeah, I'm a plus, okay.
It even tells you precisely what data it will train on your historical sales data and where the resulting model will be stored within BigQuery. This is a huge time saver for understanding these advanced machine learning concepts, especially if they're new to you. It bridges that gap between the code and the actual concept.
But what if ARMA Plus is new to you?
No problem. You simply ask Gemini in the chat, what is an ARMA Plus model type? What functionalities does it have?
And it explains the algorithm.
It does. Gemini explains that ARMA Plus isn't just any time series model. It's a sophisticated algorithm designed to handle complex patterns like seasonality.
Like weekly or monthly sales cycles.
Exactly. Daily, weekly, monthly cycles in sales. Also long-term trends and even sudden changes or outliers in your data. This makes it incredibly powerful for accurate long-term forecasting, especially when your sales data exhibits these nuanced temporal dependencies.
But maybe more complex to run.
It can be more computationally intensive compared to simpler models, yeah. But Gemini explains that trade-off too.
This capability, having this explanation right there, feels invaluable.
It really is. It's like having a quick in-console encyclopedia and a personal machine learning expert that explains complex technical terms and algorithmic capabilities without you ever having to leave your workspace or open another browser tab. It demystifies advanced concepts on the fly.
Okay, so the analyst understands the model creation query. They run it. BigQuery ML trains the model. What's the next step?
Once the model is created and trained, which BigQuery ML handles with impressive speed, you then ask Gemini the next logical question. How can I get a forecast in SQL from my model?
And Gemini gives you the code.
Immediately. Provides the precise SQL query to generate a forecast using the ML forecast function call.
So you just need to tweak it slightly.
Exactly. You make a couple of quick adjustments to the generated query, for example, specifying that you want to forecast 7 days out, maybe with a 95% confidence interval, to understand the range of likely outcomes and run it directly in BigQuery Studio.
And the result?
You instantly get the sales forecast for the next 7 days presented directly in your query results. Boom!
That's remarkable, going from raw data to actionable predictions in minutes.
Consider this. Within maybe 15 to 20 minutes, you, as a new team member, have gone from being completely unfamiliar with the data
To understanding its structure.
analyzing it with complex queries.
And even building a basic yet powerful time series forecasting model.
And the best part, you never had to leave the BigQuery console to search for answers, look up SQL syntax, or try to understand complex machine learning algorithms from scratch,
Gemini was the constant, intelligent assistant throughout the entire process.
making you productive and confident right from day one. This really demonstrates how these tools fundamentally empower new users to be incredibly efficient and contribute meaningfully to their teams almost immediately.
It drastically reduces that traditional onboarding time. Weeks cut down to minutes or hours.
Exactly. Okay, one more scenario. Let's dive into another powerful application, this time from the perspective of a data scientist.
All right, what's the challenge here?
Imagine you're working at an online store, maybe an e-commerce company. Your marketing team approaches you with a significant challenge. They need help finding the best customers for their next big sales campaign.
A classic marketing request.
Right. They want to segment customers into 5 distinct groups based on their shopping habits, things like how often they buy, how much they spend. And critically, they need actionable, personalized ideas for each of those groups, not just segments, but strategies.
So, our data scientist, recognizing the power of integrated data and AI,
Decides to leverage BigQuery Studio and Gemini to achieve this quickly and efficiently. This isn't just about number crunching. It's about translating raw customer behavior data into tangible, high-impact marketing strategies.
Okay, walk us through the process. What's step one?
First things first, you need to get your lab ready. That means enabling BigQuery Studio if it's not already. You navigate to the Google Cloud Console, find the BigQuery page, and enable the new code management features within BigQuery Studio.
So basically turning on the advanced tools in your integrated data science environment.
Pretty much, all necessary APIs get enabled seamlessly behind the scenes for you.
Then what? Notebook time.
Exactly. In BigQuery Studio, you then create a new Python notebook. This serves as your digital notepad and interactive workspace, where you'll write code, run analyses, visualize results.
You choose a region for compliance.
Right. Choose a specific region to store your work, ensuring data residency and compliance. Then you connect to a runtime.
Explain runtime again briefly.
Sure. When you execute a Python notebook in the cloud, it needs a dedicated computational environment, processing power, memory, libraries to actually run the code. That environment is the runtime.
Like a temporary virtual machine.
Effectively, yeah. A virtual machine instance provisioned on demand. You do this by creating a default runtime, essentially powering up your analytical compute resources.
Okay, lab powered up, need data storage.
Yep. Next, you create a new beta set in BigQuery called, say, e-commerce to securely store your customer data. Think of it like organizing your raw customer materials in clearly labeled containers within your high-performance data warehouse.
And finally, connect everything.
Right. You paste in some initial Python code to import necessary libraries, pandas, BigQuery clients, Vertex AI SDK, and connect your notebook to BigQuery and Vertex AI, where the generative AI models reside. Run these initial cells, link everything up, and your workspace is ready for action.
Setup complete.
Yeah.
Now, getting the actual data.
Now that the lab is set up, it's time to get and prepare the core customer data. You might start by creating a base table in BigQuery with your e-commerce data, crucial customer purchase history, like order dates, product categories, total spend.
And you can run SQL right from the notebook.
Exactly. BigQuery Studio lets you run BigQuery SQL directly from your Python notebook, which really streamlines that data import and preparation process.
So data's in a table. How do you start working with it in Python?
With the base table ready, you then leverage Gemini's Generate with AI feature again. You simply type a request in plain language, like, create a BigQuery data frame with the table I just created and show me the top 10 records, just to quickly inspect the data.
And Gemini writes the Python code for that.
It does, automatically converting your natural language request into the precise Python code using the BigQuery client libraries to pull data into a data frame.
Give us that lab assistant analogy.
It's like telling your AI lab assistant, retrieve a sample of the raw customer data from our BigQuery storage, load it into our Python working memory as a data frame, and display the first few rows so I can quickly check the structure. And the assistant instantly does it, saving significant manual coding effort and ensuring the data is correctly loaded.
The benefit, again, being speed and reduced coding effort.
Absolutely. Gemini saves a lot of time by generating that complex SQL and data frame code. It automates the heavy lifting of data preparation and exploration, allowing the data scientist to focus on the higher-level analytical tasks, like the segmentation itself.
Okay, data's prepped and in a data frame. Time to segment those customers based on marketing's requests.
Right. Time for the core analysis. You use Generate with AI again within the notebook. This time you instruct it to do a few things.
Like what?
First, maybe split your customer data into test and training sets.
Why is that important?
It's absolutely essential for building a robust, unbiased machine learning model. You train the model on one part, training set, and then evaluate how well it performs on data it hasn't seen before, test set. Prevents overfitting.
Makes sense. What's the next instruction for Gemini?
Then you ask it to create a k-means clustering model with 5 clusters, exactly as requested by the marketing team.
K-means. Explain that briefly.
Sure. K-means clustering is a very common unsupervised machine learning algorithm. Unsupervised means it finds patterns without predefined labels. It groups data points into a predefined number of clusters, in this case, 5, based on the similarity of their attributes.
And the attributes here are?
Things derived from the purchase history, like recency, how recently they ordered, frequency or order count, how many orders they've placed, and monetary value or spend, how much money they've spent in total or on average, often called RFM analysis.
RFM. Got it. So how do you phrase that request to Gemini?
You'd tell it something like, take this customer RFM data, split it into training and test sets. Then create a k-means clustering model using BigQuery ML with 5 clusters based on recency, frequency, and monetary value. Save the trained model to my BigQuery dataset.
And Gemini generates the Python and BigQuery ML code to do exactly that, training the model, saving it.
Yep. Automates the entire model building and training process, which usually involves quite a bit of boilerplate code.
Model trained. Now apply it.
Exactly. Once the k-means model is created and trained, you use Gemini again. You prompt it to apply this trained model to your entire customer data and assign each customer to one of the 5 newly identified clusters.
So now every customer has a cluster label, 1 through 5.
Right. You're automatically classifying your customer base based on their calculated behavior patterns. That's a crucial step for targeted marketing.
But just having a label isn't enough. You need to understand what the labels mean.
Precisely. And visualize them. To really make sense of these groupings, you ask Gemini to generate Python code, maybe using a library like Matplotlib or Seaborn.
To create a plot.
Yeah. The request could be to create a scatter plot, maybe plot day since last or recency against average spend, monetary value, with each data point representing a customer colored by its new centroided, which is the cluster label.
Give us the analogy for that visualization request.
It's like telling your AI assistant, now show me a clear visual representation of these customer groups I just created. Plot how much they've spent on average on one axis and how long it's been since their last purchase on the other axis. Use different colors to highlight each of the 5 customer segments.
In the result,
You get an immediate visual representation of the clusters directly in your notebook. You can instantly see the distinct groupings, maybe high-spend recents in one corner, low-spend infrequent buyers in another. This rapid visualization is absolutely key to understanding the segments and making data-driven decisions.
okay, segmentation, done, visualized. But marketing wanted actionable ideas.
Right. This brings us to the most impactful part of this scenario. Unlocking truly actionable marketing insights by leveraging large language models. This is where you go the extra mile.
Moving beyond just segmentation to strategy generation.
Exactly. First, you need to summarize what each cluster actually looks like statistically. You create a new data frame, maybe using Gemini's help again, that shows summary statistics for each of the 5 customer clusters.
What kind of stats?
Things like the average recency, average frequency, average monetary value, maybe the count of customers in each cluster. This gives you a clear quantitative profile for each group. Cluster 1, high spend, frequent, recent. Cluster 2, low spend, infrequent, lapsed, that sort of thing.
Understanding the defining characteristic.
Right. Then, a small but important technical step. You convert the summarized cluster information into a simple string format.
Why a string?
Because it makes the structured summary data easily digestible and readable for a large language model. You're basically packaging the cluster profiles neatly for the AI.
Okay, data prepped for the LLM. Now the prompt.
Now for the big moment. Prompting the LLM. You'd use the Vertex AI SDK in your notebook to call, say, generative model, Gemini 1.0 Pro. You define a detailed multi-part prompt. This is crucial. You carefully instruct Gemini to act as a creative brand strategist.
Setting the persona and the goal.
Exactly. Sets the persona and the expectations for the quality and type of output you want.
And what specific things do you ask for in the prompt?
The request is highly specific. Given the detailed cluster summary information you've just provided in the prompt, you ask Gemini to generate, for each cluster,
Okay.
a compelling persona name like the Loyal Luxuries or the Sporadic Bargain Hunters, a catchy title for the segment, and most importantly, specific actionable next marketing actions for that specific cluster.
Examples of actions.
Things like personalized email campaigns focusing on loyalty rewards and early access, or targeted social media ads showcasing new arrivals in their preferred categories, or re-engagement campaigns offering a discount on their next purchase, or flash sales promotions on complementary products, really concrete stuff.
Give us that AI strategist analogy one more time.
Okay. You hand your incredibly insightful AI strategist assistant a detailed statistical profile of each customer group you've just identified through clustering. Then you ask it, okay, you're our marketing guru. For each of these 5 distinct customer groups, please give them a fun, memorable name, describe who they are in a nutshell based on these stats, and then outline specific, concrete marketing steps we should take with them. What kind of email should we send? What types of offers will resonate? What messaging strategies should we use?
And you feed this prompt to Gemini Pro.
Right. Use Generate with AI or the Vertex AI SDK call within your notebook to send this carefully crafted prompt, including the cluster summary data, to the Gemini Pro model.
And the payoff.
The incredible payoff is almost instantaneous. The LLM quickly generates fantastic, personalized marketing recommendations for each cluster. You get creative titles, vivid personas, and highly actionable steps, all presented in a structured format, maybe Markdown or JSON, that's easy to copy, paste, and share directly with the marketing team.
That step, generating the actual strategy, sounds like it saves immense time.
Oh, absolutely. This entire step, which normally takes hours, maybe even days, of manual brainstorming, poring over spreadsheets, competitive analysis, and creative ideation from human marketing strategists,
Is done how fast?
is done in minutes by combining Gemini's powerful generative AI capabilities with your securely stored and analyzed customer data right there in BigQuery. It's a profound leap in efficiency and strategic output quality.
And presumably, you can then clean up the resources used.
Yeah, good practice. The labs and documentation usually provide clear instructions for cleaning up the created BigQuery tables, models, and notebook runtimes afterward, ensuring responsible resource management and cost control.
Okay, so those are three really powerful examples. What's the big picture here? What does this all mean for the modern data professional?
Well, we've journeyed through three distinct, incredibly powerful applications of BigQuery, Gemini, and Vertex AI working together.
We saw transforming reactive manufacturing into proactive operations,
Empowering a brand new data analyst to quickly master sales forecasting.
and enabling a data scientist to unlock deep customer insights and generate actionable marketing strategies at unprecedented speed.
What stands out time and again across all these scenarios is really the sheer speed.
And the intuitive interaction.
Yeah, using natural language.
Exactly. The intuitive natural language interaction and just the profound ability of these tools. They don't just extract data anymore.
No, they generate intelligent insights, they make accurate predictions.
And even create concrete, actionable recommendations pulling from structured and unstructured data, all while keeping your valuable proprietary data securely managed within the robust Google Cloud ecosystem.
So the core takeaway here isn't just automation, is it?
No, I think that's key. It's not just about automation, which simplifies existing tasks. It's fundamentally about augmentation.
Augmenting human capability.
Right. They empower data professionals, engineers, analysts, scientists, everyone in the data sphere to be exponentially more productive, more creative, and ultimately far more impactful in their roles. They reduce the drudgery, the manual tasks.
Allowing that valuable human expertise to focus on the more strategic elements, problem formulation, critical thinking, interpreting results, innovative application. It truly feels like a secret weapon in the modern data-driven landscape.
Elevating the human role rather than just replacing tasks.
I think so. Which leads us to a final thought, a provocative question for you, our listener, to perhaps ponder.
Okay.
What kind of previously impossible insights or automated intelligent actions could these powerful integrated tools unlock in your field within your specific organization or industry?
And maybe how might this dramatic shift in productivity and capability redefine the value of human expertise and strategic thinking in the years to come? Where do people best focus their efforts when the tools become this powerful?
Something to definitely mull over.
Absolutely. Thanks for joining us on this deep dive.
See you next time.